Hello there, integrated science students, and welcome to our second video lesson here over rocks, more particularly igneous rocks. Okay, so here we are in Unit 3, Earth's Materials. We've knocked out minerals. We know one part of the building blocks of rocks. Now let's go ahead, let's get into the three rock groups, the rock cycle, and in today's lesson, we're going to cover one of those rock groups being igneous, the igneous rocks. Okay. Three major topics for the video today. We're going to start off by defining a rock and talking about how we classify rocks or identify rocks from one another. Then we're going to get into what an igneous rock technically is, okay, the definition of an igneous rock, and then the actual two major types of igneous rocks. All right, so three little topics for the video today, and let's get started right now with the official definition for a rock. It is a naturally forming mixture, typically of minerals, rock fragments, or volcanic glass, those three items, that is bound together. Okay, so a naturally formed mixture of minerals, rock fragments, volcanic glass, some combination of those three, that is bound together. Notice I didn't say chemically bound together. All right, it's a physical relationship that's present here for this rock. Mixtures are typically items or substances that can be broken down physically. And that's exactly what a rock is. It's a lot of other little things bound together, held together. Okay? It's just the unique properties of those items that allow them to be bound together for long periods of time. So, anything that's naturally formed and is a mixture that's bound together, typically a mixture of rock fragments, minerals, volcanic glass, it's a rock. There you go. Okay? Now, when we want to identify one rock from the next, we want to look at two things, that being texture, one of those two, and composition. Texture, we are going to look at the size, shape, and arrangement of the items that are present in that mixture. Okay, so what's the size, shape, and arrangement of the minerals, the size, shape, and arrangement of the rock fragments, the size, shape, and arrangement of the volcanic glass? That's texture. We also may refer to texture from time to time as how it feels or what you feel when you touch it. Okay, composition is the average chemistry. Notice the key word there, average chemistry of that rock. So what's the average chemical composition of that mixture? On average, what elements are present and how many of each element is there? It's an average because, again, it's a mixture. It can have a little bit less of this or a little bit more of this and still be classified as that rock or a known variation. Okay? So, in review here for our first part, a rock defined as a naturally formed mixture, typically of minerals, rock fragments, and volcanic glass that is bound together for an extremely long period of time. And we want to identify rocks by examining their texture and their composition. Next video topic, igneous rocks. The first group of rocks that we're going to look at and we are going to begin identifying. We look at igneous rocks because igneous rocks, by definition, are rocks that form from the cooling and crystallization of molten rock, and molten rock is defined as magma. So igneous rocks equal rocks formed from the cooling and crystallizing of magma. Okay? We start with igneous rocks because usually they're the easiest to identify, and the process for forming them is the easiest to understand. It's got the least amount of moving parts to it. You got magma, it cools, the minerals crystallize, voila, you have yourself a rock. Alrighty? Now notice these mixtures are a little bit different because mainly for igneous rocks, you're just talking about a mixture of different minerals. Rarely do we find other rock fragments present, but it's rare. And we do get the volcanic glass present with this. All right, and we'll be identifying volcanic glass and glass. So igneous rocks, any rocks that are formed from the cooling and crystallizing of magma. Now, there are two major types of igneous rocks, and they're all about the environment in which they formed. We've got ourselves intrusive igneous rocks and extrusive igneous rocks, and there's a lot to be learned just by looking at the prefixes of each one of those first terms. Intrusive, I-N, meaning inner, inside, and extrusive meaning exit, outside, outer. So intrusive rocks, take 2 seconds here and think, where might they cool and crystallize? Haha, yes sir, and yes ma'am. Intrusive rocks cool and crystallize beneath the Earth's surface. And because of that cooling and crystallization beneath the surface, it gives those rocks some very, very special properties. Extrusive rocks, where do they form? Think. That's right! Extrusive rocks form on the outside of the surface, so above the surface. And because of the cooling and crystallization above the surface, they have some special properties that are unique to them and different than their intrusive brethren. Okay? So intrusive rocks, because the cooling and crystallization happens beneath the Earth's surface, it usually happens at a lot slower rate. Okay? They're closer to the heat source. Minerals have to freeze. They freeze at very, very high temperatures. And if you're close to that super high temperature, it's going to take longer and longer for you to cool down. Because the cooling process is longer, intrusive igneous rocks form large grained crystals that you can usually see visibly the minerals that are composing the igneous rock. Extrusive rocks, on the other hand, form outside of the Earth's surface. The cooling and crystallization happens much faster, and because it happens much faster, those crystal sizes, those crystal grains cannot expand and grow as large, so they're very fine and small-grained crystals that are found in extrusive igneous rocks. Also, because of the cooling above surface with extrusive igneous rocks, you can get yourself some capturing of gases that are then slowly released during the cooling and crystallization, and that can give those extrusive rocks a really interesting texture. All right, and we've got 2 of those being vesicular and also porphyritic. Okay, vesicular, big, obvious pores running through the igneous extrusive rock, and porphyritic, very light, but much, much smaller pores, and to some degree, invisible pores that are running through that entire extrusive igneous rock. Okay, so we've got the definition of an intrusive, we've got the definition of an extrusive. Now, notice that really they're only different on a physical level. It's going to be the same type of magma that's forming each, whether it be cooling underneath or above the surface. The same type of magma is going to form each one of these rocks. So, the chemical composition between some of these different rocks, whether they're intrusive or extrusive, is very, very, very small. Okay? There's a great diagram in your textbook on page 821 that kind of outlines this. 3 types of magma. 3 types of magma that form igneous rocks. Felsic, intermediate, and mafic. And those terms should look familiar to you from our volcano studies back in Unit 2. Felsic rock contains a lot of silica. Okay? Contains a lot of silica. Alright? And if it cools above the surface, you're going to get yourself certain igneous rocks like rhyolite. And if it cools below the surface, you're going to get nice, pretty granite. The stuff that they like to put on countertops and fancy upper scale kitchens. If you've got an intermediate magma composition, so something that's kind of felsic, kind of mafic, contains some silica but not a lot, you get yourselves diorite if it forms beneath the surface, and andesite if it forms above the surface. We're going to identify each one of those in class. Okay? If you've got a mafic magma, so it's very, very runny, doesn't contain a lot of silica, if it cools underneath the surface, you're going to get yourself gabbro, and above the surface, you're going to get yourself what we call basalt. All right? Now, granite and rhyolite, very similar composition. Diorite and andesite, very similar composition. Gabbro and basalt, very similar composition, but all different rocks because of where they cool and crystallize. Alrighty? So, in review, covered a lot of material very quickly here, but in review, we should know the definition of a rock, how we classify and distinguish rock type from rock type. Okay, 2 items there, texture and composition. We should also be able to define what an igneous rock is in general. You got to be able to tell me a little bit about intrusive igneous rocks and extrusive igneous rocks. How are they different from one another? And then you got to be able to walk me through the 3 types of magma and where those magmas might cool to form what rocks. Again, check the diagram that's on page 821 in your textbook, and make sure you read Section 2 and complete the directed reading Section 2 worksheet for class. If you have any questions, shoot them my way. I'll see you guys.